Welcome, mathematicians. In this video, we're going to summarize the three basic forms of a quadratic function, along with efficient strategies we can use for each to find the key features of the function, the vertex, the y-intercept, and the x-intercepts, if any. As a quick reminder, you can use either y or f of x to represent the output of the function. They're used interchangeably. In this video, I'm going to primarily use y. We're going to use a table to organize all the information that we're going to find. And here's the structure of our table. I filled in the generalized version of each equation along with an example. Sometimes it's helpful to think about an example when you're thinking through how to find each of these key features. One quick thing to highlight is the factored form. We're subtracting here and here. It's very subtle. And we'll talk about why we do that a little bit later in the video. We've focused primarily on standard form and vertex form, but factor form is also a helpful form for us. Now, brain research tells us that you learn when you retrieve information, when information comes out of your brain, versus when you store information when it goes in. So to maximize your learning, I want you to pause me, fill in this table as much as possible. Feel free to review your notes if you need to along the way, and then come back once you have something for each cell in the table. Welcome back. If you feel like your table is already good to go, why don't you zip right to the end of this video and just compare your thinking to my thinking and just compare and contrast that. We're going to now go through each one individually, and we're going to start with standard form. To find the vertex of standard form, we first find the x value. And we use a really great little pattern to do that, which is negative b over 2a. Once you substitute that in and simplify it, you have the x value of your vertex. To find the y value, you're just going to substitute the x value into the function and solve. So I'm going to say substitute x value and solve. So input that x into the function and see what comes out. The y-intercept, an important reminder for your y-intercept, x is always equal to 0. So for standard form, to find the y-intercept, when you set x equal to 0, the y-intercept is always c. So this is really helpful. It's really easy to find the y-intercept in standard form. Finally, for the x-intercepts, reminder here is that y is always equal to 0 for the x-intercepts. So when y is equal to 0, we have 0 is equal to ax squared plus bx plus c. Beautiful quadratic equation here set equal to 0, and we have three strategies. First, see if you can factor. If you can, then you can use the ZPP, zero product property. Typically the most efficient way to go if possible. Next, if you can't factor in ZPP, you can maybe complete the square. That will always work. Or you can always use the quadratic formula. So to find the x-intercepts, you have to do a little bit of work, but you have multiple strategies there to solve the equation. Next, let's move on to vertex form. It shouldn't be surprising, but with vertex form, it's super easy to find the vertex. It's simply h, the number being subtracted from x, and k, done there. Y-intercept is also easy. Since x is equal to 0, substitute in 0 for x and solve for y. So we're going to substitute 0 for x, solve for y. Nice and easy. And then finally for the x-intercepts, again, y, or the output, is equal to 0. So we're going to have 0 is equal to whatever our function is. And this is great. This is all set up to use the square root method. So always use the square root method to solve. It's always, always, always going to be the most efficient strategy in this situation. Great, vertex form. Finally, let's look at factored form. To find the vertex with factor form, we have two strategies, really. The first one is very elegant, and it utilizes what we know about symmetry in a quadratic function. We know that the x value of the vertex will be halfway between the x-intercepts. Think of that as the axis of symmetry. So halfway between x-intercepts. So in this, if you want to use this strategy, you're going to find your x-intercepts first. I just want to use this example that we have up here. Here, the x-intercepts I know are 1, 0, and -3, 0. So halfway between that is if I took the average of those two numbers, that's equal to -1. So I know the x value of the vertex -1. Great. If you like symmetry, go for it. The other way takes a little bit more work is you can convert to standard form. And to convert to standard form, you're going to multiply those binomials. Multiply the binomial. So a little bit more work. Once you're there, you can use the little pattern x is equal to -b over 2a. In either case, once you found your x value, you'll substitute it into the function to find the y value. Y-intercepts, same thing, x is equal to 0, so we're going to substitute 0 for x and solve for y. Nothing new there. Again, nice and straightforward. I know I have too many t's there. You know what I'm talking about. And solve for y. Last but not least, the x-intercepts for the factor form. This is super easy. Again, y is equal to 0, so our entire function is equal to 0. And because it's already factored, we can use the ZPP. And we know that each factor could equal 0. Now you're going to see something magical that happens. If I add m to both sides, that means my x-intercepts are either m or n. And this is why we have that subtraction there that I talked a little bit about in the beginning, because that means we're subtracting the actual x-intercepts, and super easy to find those here. That was a lot. I hope this video really helped you summarize and solidify everything you know about the three forms of the quadratic function and how we can be flexible with our strategies and use efficient ways to find the key features, the vertex, the y-intercept, and the x-intercept. These key features are super helpful when we're solving different types of application problems or when we're graphing a quadratic function. Once you have those key features, you plot those points and you've got your parabola. All right, mathematicians, math on.